Yep, it looks good to me.
Great.
I'm also recording, by the way.
Sounds great. All right. Cool. All right. I got the chat open. Let's go ahead and get started. Yeah. So introductions. Mike Purvis. I work at Near Protocol and the DevX team. At DevX is short for like developer experience. So we try to get like either hackathon people, college students, anyone who's curious. Whether you're tinkering or trying to get like a real startup going on Near, developer experience kind of like paves the way for you. We help with the tooling to make things easy, all that jazz. And if you want to reach out to me, I'm mike.exe everywhere, and I'll definitely be in the Discord. I'm in the mentor channel too. And thanks for all the great questions already today. This is really inspiring. It looks like people already have great ideas, and I'm very excited. Okay, yeah, so this is going to be sort of part presentation and part hands-on, actually. What we're going to do is all these bullet points listed out here. And I think that one thing that I like to do in this workshop is to do something that is sometimes missing in blockchain. I think you hear the word blockchain over and over again. And once you start reading like blogs about it, you see all these acronyms like BFT, NFT, POA, WASM, all this jazz. And it's just sort of like skimmed over like what is actually the fundamental part of blockchain. And so we're going to get to the Rust pretty soon, but I think it's worthwhile to have like a little bit of a crash course into like, what are we doing? And like, what is a smart contract? And how does this all like come about? Especially when it comes to WebAssembly. And I think WebAssembly is something that would be really exciting for, if I was in college right now, I would just love to be diving deep into that. WebAssembly is very important in the Near protocol blockchain and other blockchains as well. Okay, so we're going to have something of a kind of like a pub crawl where we're going to visit like a few really useful sites. I've spent some time kind of curating interesting sites so that you don't have to go and find all of these. I'm going to do my best to be pasting these into the Zoom chat so that you can just quickly click on them. There are some links on the right-hand side. You don't need to worry about that. I will have like easy bit.ly links as we go. And so like, I'm also going to be having these reminder ribbons, as you see in the bottom left-hand corner. We're going to be going through some basic, like, here's how you do a super simple like Rust program, like basically like hello world, right? And then we're going to see, step it up slowly and slowly. And we're going to see a few things that will be very familiar once we get to the blockchain, actually. So those reminder ribbons are sort of like a cue to like, keep this in mind. Now, other workshops, you may be like downloading like giant dependencies and, eager to get those going like immediately because Rust is not a tiny dependency. For this workshop, don't worry about it. We're going to use this really cool thing. If you were in the last session about Gitpod, we're going to be using that one. So that's going to take care of it all for you. So you can just kind of sit back for now and know that like you'll have an environment that's just like completely set up. Now, if I were in the audience, I think the way I like to like experience this workshop is to have like this presentation in one window or one desktop, and then have like another one open on the side, so you can either see both or just know that we're going to be like flipping between one and the other. I will try not to make us seasick as we do that. And so when you walk away from this presentation, it's going to go kind of fast, but you should be able to write a simple Rust smart contract, compile the Rust into WebAssembly, and then make your own account and push up your smart contract to that and be able to use CLI commands and even have like a web front end that you can like click on it and it's going to talk to the blockchain. So that's like the takeaway that we'll all be able to do at the end of this. All right, cool. So let's use the chat again. So as a show of hands, you want to type 0 if you've never used Rust, 2 if you've like kind of played with it, did like a hello world or something. Zeros, good. Yeah, I was a 0 like months ago. Yep. It's really cool. It's a systems like programming language. And so that means like, unlike say JavaScript or Python that are interpreted, this is going to be like compiled. So it actually goes down to like low level instructions and says, we are moving this, piece over here, just very low level. And here is a link. My first link that I'm posting is kind of like the official Mozilla site for Rust. And there's a bunch of videos there. It's super approachable page. It's not going to get into crazy detail, but I'll read a couple of important quotes from one of the videos. There's like, I don't know, 9 or 10 different 3 to 5 minute videos. One of the quotes in there, it says, "Thread safety in Rust is preventing entire classes of safety and security bugs that you see in C and C++. So C and C++, I know we did that when I was in computer science in college. Probably you all have done that too. Not as fun as some other languages necessarily, but you can like handle every single piece of the memory, and like sometimes you're in charge of like deallocating memory and all these very important systems kind of programming. And so when it comes to things like the blockchain, and obviously you can control store of value and like money, and maybe part of your portfolio is in blockchain, we need some kind of language that's going to be like bulletproof, right? So Rust is basically that answer for near. In the last workshop, we saw that you can also write smart contracts in assembly script. It's not TypeScript, but you could be fooled. It looks super similar. So TypeScript is like, I think of TypeScript as like, sorry, assembly script, I should say, as like, I wake up on a Saturday, I crack a LaCroix, and I want to like hack away on some like blockchain game. I might use assembly script. If I'm trying to make like the next like, cash app that's like decentralized and you're handling millions of dollars, you want to use Rust. Or else if you're just really curious about Rust and want to get into it. So that's the differentiation there. Okay, here we go. Here is the second link, and this is going to be a little interactive. So this is something to paste into a window somewhere. It's going to be a little hard for me to jump around, so I'll just trust that folks are kind of opening that up. And we are going to look at something super simple here. And this is a counter, just bare bones, a little bit different than a hello world, but not that much more complex. Let me see if it's going to be easy to share that screen. Well, I guess you can see that, can you? Cool. So here we have a counter struct. And a struct is kind of like a pared down version of like a class. That is also something that you may have seen in previous like computer science terms. And so this is like not a weird way to do things. This is actually like the Rust way. This is not a blockchain thing. Again, we're starting from like scratch of like, here is a thing you do in Rust, period. We'll add in blockchain later. So we have a struct up here. And in this struct, we say, okay, we have like one variable called val, and then you give it a type. So this could be like string, it could be like a map, it could be a set, one of the various data types. This is an I8, so it has like, 8 bits to it. And it's signed. So that means that it's not a negative number. Or sorry, it can be. It's signed, so it can be negative. Below that, we have the impl. So this is the pattern of like, you have a struct, then you have like an implementation of the struct. So now we're basically saying like, here are the methods that are on this thing that we just invented called counter. It could be called anything. And we have a couple of functions in here. So public is the pub, function fn, because they're just trying to save some space, get num. So this is pretty clear, right? It's like our function is called get num. And this is a little bit of a strange piece of, I guess, Rust in general, but you're going to have like references to the self. I wouldn't really worry about this. This is just like how it's done, straight up. What is this arrow here? So this arrow here is like, okay, this public function, obviously it calls get num, so you expect that it's gonna give you something, right? So this arrow means like, okay, we are going to return the type. And what type are we returning? We're returning I8, right? That makes total sense because all we're doing is we're returning our self's val, which is also I8, right? So in all cases, when you have a simple function like this, like the type is gonna match that guy. Okay, then next one, just kind of breezing through this, we have something different here, public function increment. And now we have this reference to a mutation at mute self. Or so it's saying like, we have our self and it is now mutable. We are saying like, hey, we are going to like mutate this thing. If you've heard of like accessors and mutators, there's also the term like, getters and setters. And so this is kind of using the more clever words of like a mutator. So we're saying, we're actually going to change something here. This guy was just like returning a value. This is actually going to change something. So super simple. Our self is our self plus 1. And then here we're just going to do essentially a print line to the console saying, okay, cool, we just increased the number to this. This is like how you kind of format things. These exclamation points are kind of interesting. It seems like, why would I need an exclamation point for something so simple as like, printing a line? This is like a macro, and there's a whole section on this in the official Rust book. I won't really get into it. It's not necessarily super scary. If you want a deep dive, we're going to talk about the Rust book in a bit. And kind of breezing through this, decrement is like basically the exact same thing, right? Copy paste. This is minus instead of plus. So we've set up our data structure, right? Here is our counter, and then we have like methods on that counter. And just like in other languages, you have like an entry point where you say, okay, when I like run this file, where should I start, right? Main is the entry point. We're saying, okay, let's initialize this counter to the value is 0, since we have val up here. And we're going to straight up call increment, and we're going to say, hey, after incrementing, your number is this. It's like super simple. In the upper left-hand corner, you can run this guy, and no surprise, you can see after incrementing is 1. Yeah, so this is kind of a cool place if you are feeling like, I don't really know how to do Rust yet, I don't want to do the blockchain side of things, so there's a little bit of a different approach, then you can always just play with this playground and kind of like get more familiar. So back to the slides real quick. I think this is showing there. So one thing that we should notice here is we're talking about the blockchain eventually, right? And there is no like main function on the blockchain. It's kind of like a function. It's like a little teeny piece of code that like lives on the blockchain. And you actually, like, yeah, you can't have like an entry point there. So that's something that we'll have to ignore in this particular example. We'll go over this pretty soon, but this nice interface with that playground was just sort of like, it's called a playground, so it doesn't have the actual files that you need. And you're going to actually need different files like this cargo.toml, set up dependencies, all this jazz. So just know that like, we just ignored that in the last place. And there's no print line in the blockchain, right? And this is a good time to just think about like fundamental assumptions of programming. Like when when I was in college, I think almost everything was like, C# or C++, and you could always print the command line because there's like a standard out that you will see somewhere, right? Well, the blockchain doesn't have that. So we need to start like switching the way that we think of like, what can we do on the blockchain? Like, if I tried to implement a function that like made a loud beep, right? There's no speakers in the blockchain. So like we need to like kind of think right now in our heads about like how different this environment is from what we're used to. Okay, I think we covered this pretty well. I'm gonna move along to the next one. Oh yeah, so if you have that tab open too, one thing you can check out is in the upper left-hand corner, right next to where we pressed that run button, there's 3 dots. You can click on that, and all the way to the bottom, there's a WASM. That's how you pronounce the WASM, and it says, build a WebAssembly module for web browsers. And then on the right-hand side, once you do that, it's gonna show you kind of like that lower level, those lower level instructions actually. So you see like set, add, get, and this is just like the bare bones, like what's happening behind the scenes, and some crazy people that I know at Near can actually just like read this stuff and understand what's going on. So that's kind of a cool glimpse, at least. We're not going to dive into that, but it's a cool glimpse of like, even this simple like counter is like a lot of those instructions. This is a a peek into how like the compilation is basically going to be working here. Okay, this is a really awesome resource. I think that this is super worth just messing around with after this workshop. This is the official like Rust online book. And it does a great job of just like introducing you to things. And then here's a chapter here, chapter here. I say like the first 3 chapters, maybe 5 if you want to, will take you like, 35, 40 minutes or something, and just really give you a good idea about like what's weird in Rust. Rust is one of those ones where you don't necessarily want to jump straight in and be like, oh, I'll just get it immediately. It does make sense to be like, wait, what is this like pattern matching thing going on? And anyway, that's the reference for you. That'd be really helpful. So what I have here on my screen is the kind of just snippets from the Rust book, and this is the very first example. Good old hello world, essentially. They're calling it guessing game. And you see what I was talking about earlier. In the upper left, we see there's this cargo.toml file. If you have done JavaScript development or even just used JavaScript for kind of building stuff, this is similar to like a package.json file. Then down there we have main.rs, which is just super simple. The same thing we saw before, a main function, the print line, hello world, right? And then on the upper right-hand corner, we've got cargo run. This is how you're basically running it. So like similar to like Python, whatever, Node, whatever. This is how you run it. Cargo is something that gets installed when you install Rust. Again, Rust is kind of like a big dependency. And so cargo isn't like unrelated to Rust. It is like how you build and run Rust apps. Then below that, we got our first reminder ribbon, and where it says cargo build, and that's going to basically say, okay, cool, we got this code that you wrote, print line, hello world, and it's going to compile it. Okay. So let's keep that in mind. Now let's talk about some WebAssembly basics. So this is a rad site. I actually reached out to this guy on Twitter, and he's like a skateboard riding, dreadlock wearing DJ. He's like super awesome person, and this is one of my favorite sites for understanding just WebAssembly. And he happens to have an example of like writing a web app that's like Rust compiled to WebAssembly, and then you have a simple little web page that's going to be calling a function inside of the Rust binary, which is awesome. So we're going to like move through this pretty quick. There are a couple things that are of note here. In this example, he is actually not using this main.rs file, which is a difference. He says to rename it to lib.rs because it's going to be a library. That is something to keep in mind because, spoiler alert, that's what we do on the blockchain too. We're building smart contracts. And then when you look at the actual Rust code, you see that like there's that function add. So this all looks familiar. We saw a public function, and we saw that it returns like an I32 over here, all that jazz. And above that, though, we see like #WASM _ bindgen. And I'm not the right person to tell you like exactly how these kind of macros work, but I love how he says it in the comments above here. He says, this is like an exported function, right? And the way I think about it is like, you put that macro above a function and you say, hey, see this function? I'm gonna do something special with it. And I want to like kind of make it available like outside of this. And so this is the example for building a web app. And lastly here, when he's compiling this, before we get to the actual like web page, before we saw it was like cargo build, right? This is like WASM pack build. And then there's a flag here, target web. And that's interesting. It's similar to what we saw before, but we have this extra target. Okay, let's keep that in mind. And then here is the JavaScript file. Kind of a few lines of code to look at. Don't really worry about it too much. I would place your eyes sort of in the middle there, where we are saying like, okay, we're initializing this hello world bg.wasm. So the .wasm is like the compiled file that we just did. And then right below that, we are saying in JavaScript, we're saying, hey, call that add function. And sure enough, it works. And this is what it looks like. So this is actually a really big deal for the web, because before, like a lot of engines are just like, hey, if you want to write something advanced, do it in JavaScript. This is saying like, hey, you can use a systems programming language and like compile it, and then your website can like, boom, like call a function on there. That's actually a really big deal. So that's why it's called WebAssembly, is it was like built kind of for the web, and Chrome and Brave and a bunch of different engines are starting to say, hey, this is a really good like virtual machine actually. Turns out in blockchain, we were like, hey, this is a really efficient virtual machine. And sure, it's called WebAssembly, but this is way better and way more efficient than trying to create our own virtual machine. And so Near and other blockchains were like, hey, we're actually gonna use this instead of kind of splitting our attention and trying to like make our own. So kind of like sort of final thoughts on this. On the left-hand column, we see that in the Web 2 world, we are like compiling Rust into WASM, and then the JavaScript knows how to like talk to it and call that function. And in the web world, it knows about like the DOM, it knows about graphics, maybe it can talk to your camera, all that jazz. And it's interpreted by like the V8 engine, which is like, again, Chrome, Brave, some other browsers, I believe. And so that translates on the other side of the blockchain as like, this is a smart contract. It knows about blockchain stuff. It doesn't know about the DOM. There is no DOM, but it does know about like your account. Maybe like how many tokens you have, and like, are you trying to send someone something? Are you trying to send a transaction that involves doing something in a blockchain game? All that jazz. It knows about logging. So it's like two different total like environments here. Very bottom, we see the kind of differentiation between how you build this, which I think is kind of coming full circle here in Web 2, which is what we call kind of now, and Web 3 is like the blockchain future of like the open web. In Web 2, it's like WASM packed build -- target web, and essentially it's going to look real similar when we build our own contracts in Rust. It's going to be cargo build, tac target is WASM 32, a bunch of stuff. So it's not, as we go forward with this, like it may look like a lot to build on the blockchain, but actually it's very similar to how you do Rust and WebAssembly stuff, period. So my hope is that with a little bit of context here, then this will make a lot more sense. Okay, now the fun part, to see if this works. We are going to go to https near.dev, which is right. Shall paste it. Pretty easy to remember as well. Near.dev, just go there, and there's a bunch of examples. I think for this hackathon, like if I were doing the hackathon, I would absolutely go here all the time. You can see like really simple examples of like, okay, and now I'm going to store a string, and now I'm going to get a string. Now I'm going to increment something in the counter, blah, blah. So this is a good reference. And we are going to essentially find the counter example in Rust, as you see on this screen. We're going to click on that guy. And then we are going to hit open in GitPod. I'll let folks kind of go through that. I should mention, so GitPod is going to ask you for a GitHub account or a GitLab account. I suppose that is a bit of a prerequisite here. I will be going over it as well in this workshop and sharing. So if you don't have a GitHub or GitLab account, definitely get one, because that's very important, and just go through the process of like saying, yep, I'm going to log in with GitHub. So I'll give folks a little bit of time because it's a couple of clicks and whatnot. And we'll see what's happening over here. Okay, is everyone kind of logged in? May take a little bit of time. This is, here, I'll show it again. It's the counter example in Rust. This is kind of funny timing. I think that there is actually like an issue with like GitHub. So that's going to be fun to see if this is working. It seems to be working. One second. Okay, well, as this loads, I guess I'll explain why this is so awesome. And if it starts loading for you, you can go ahead and give a hi in the chat. I'm curious if this is going to be working for folks. But the reason why Gitpod is really, really cool. So we typically in software engineering, when you go out there and get a job, then you like install all this stuff. You have like a particular node version, you know, Node.js version for this one project, and you don't want to screw that up because oh no, this other project has like and needs this other version. And so Gitpod is basically like, hey, you know what? Like, we're not going to mess with your machine. We're not going to tell you to change your Python version. We're not going to tell you to change your Node version, even though there are kind of solutions for that. This is going to say, we're going to spin up a Docker container, and this is going to have like all the code, all the dependencies, just like good to go for you. And it looks exactly like VS Code, the Visual Studio Code, if you're familiar with that. That's like, you know, very popular IDE. Gitpod can use any VS Code extension, which is great. So going forward, this is like a really amazing solution for basically having an online IDE that can use any language, really. Let's see here. Let me try. Oops. Okay, 1 second, folks. Okay, well, I'll go on with the presentation. This is kind of like loading, and that's fine. Okay, back to the actual presentation. As this starts to load, I'm gonna have it kind of like in a different spot. Back to the slides. Everyone is seeing my slides now? Okay, when this does load, essentially it's going to have, here we go. Spoke too soon, boom. So now I believe you all can see this screen. Can someone confirm that you're seeing my Gitpod screen just kind of rolling around doing stuff? Great, thanks. So now we are seeing, like, again, what looks exactly like Visual Studio Code, and same kind of deal where we want to keep on the upper left-hand side to see the files. And this is our README. We can see that kind of the pretty version of the README. And down here, we've installed a bunch of stuff. So before we get into the code, there's something cool that's going on where we're going to open in our browser. This looks kind of small on your screen, but there's a small dialog that says a service is available on port 123. And we're going to open it in our browser. And I'm going to pause here and make sure folks can get to this part. It says this is a counter, but this time on blockchain. Okay. So this is going to ask us to sign in. Now, we have, it'll become clear later on that why we're going to make a new account, but this will be a lot of fun. This is how you're going to need to do it for the hackathon anyway. So let's click the sign in button. It's going to bring us to this wallet, and this is called the Near wallet, and you're going to be creating a free testnet account on on Near. And so for me, I'm already like logged into a bunch of different accounts. For you, it's going to say, hey, could you please like create an account here? So it's going to follow a few steps. It's going to look like this. So here in my presentation, back to the presentation tab, at the top we saw that you'll need to sign in to call contract methods. So you'll click the sign in, and then you'll go to this create account screen and pick a extremely clever username, create account, and then it's going to go through a couple of different steps. I think the immediate next step is going to say, hey, how do you want to have a recovery method for this account? I use email. I think it's just kind of easier. And I want to point out that when you put in like a recovery email, like we're not going to send you a newsletter or something. This is just 100% for recovery. So you go through this process, and then the last step is on the right hand. I have a screenshot. Rust counter example is requesting access to your account. And it will show your name. Here it shows merlin.testnet, which I own. And then you click allow on that. Okay, and you'll get taken to some screen that basically says like, you're done, go back now, congratulations. And when you do that, you will now be logged in, and you'll see this cute little Game Boy-like robot that's a counter. And we have a plus sign, we got a minus sign, and the plus sign, minus sign will do just what you think. It'll increase the number, just like this counter that we saw earlier. And it's super similar code to what we saw earlier. It's just kind of like tweaked so that it talks to the blockchain, right? And then there's like some fun little deals in here, like RE and LE are two buttons where he winks. This little Game Boy will wink at you. L turns on the light. So I'll let you kind of play with that and see that like when you press like the buttons like plus or minus, it's going to take a little while because the blockchain is not extremely fast yet, but that's what everyone and the whole blockchain scene is working on right now. But yeah, this is live right now. Like you are playing with the blockchain when you're doing this, which is really neat. Oh, cool. Now we're going to get here too. Okay. Has everyone got this going? You wanna throw a yes in the chat? Cool. All right, so the next thing that we're gonna do is open up the actual like file here. So if you can go away from the Game Boy for a second and back to our Git pod tab and make sure that we're in this upper left-hand corner where we're showing all the files. And it's going to be under contract, source, lib.rs, as we mentioned before. It's not main.rs, it's lib.rs. Okay, so one of the things that I love doing when we're creating examples like this is just having like tons and tons of comments. So this workshop is like kind of a bootstrap for getting people started. The comments are here for you. We spent a lot of time like making sure that it's just like exhaustive. So I hope that you can follow the links if you're like, hey, how do I do a string instead? Or how do I, make a really efficient collection? Then, we got you covered. All the comments are for that. So turning the attention to my screen right now, let's just go down a little bit. Use, we've got a couple of use, which is basically importing, not too much to cover here. Borscht is a weird name for this thing that like serializes data better than JSON and just like more efficient. Turns out that that's way better in Rust. We did some profiling on that. This is actually a very standard, we're using a very small memory allocator. And then up here we see it's very similar. So pub struct counter equal and then equals or has the value that's IA. This is literally exactly the same thing that we saw in like the first slide we looked at. But we have this above it, right? This # near _ bindgen. So this is like exactly what we saw in that one WebAssembly example using JavaScript, where they were called like, it was called WASM _ bindgen. Now it's called near _ bindgen. So it's the same sort of pattern where it's like this public struct counter and the implementation, we want to do something special to this. We want to kind of like expose it. So then you add that macro above it. And then this other one is basically saying, hey, we're going to be saving this data, this val to the blockchain. So let's make sure that we like can save it in an efficient manner, essentially. And so we have like these sort of macros above it too. Boilerplate, you just sort of like follow this example. That's how it's done. Now we go to implementing the counter. I think this is like exactly the same as what we've seen so far. Increment. Okay, we increment it, and then we have the format, and oh, look, something new. So there wasn't a print line in the blockchain, like I said earlier, but we do have this thing called logs. So we have like env log. And actually, this may be a good time to say like, like where would you see this? How can you see this happening live? So I'm going to open up real quick. Explorer.testnet.near.org. So if you're writing a smart contract, here's one that was done recently, a transaction that was done recently. When you're writing a smart contract and you're using like say a CLI tool or something, you can see it in your CLI. It'll like report back to you that env log, which is sort of like the drop-in replacement for print line in some sense. And let's just take a look at this guy. This doesn't have very much useful information, but you can also see like the env log here too. Okay, actually right here. So increase number to 2. Looks like people are working with this. So this is actually like the env log is getting returned here. So as you're developing and if you run into troubleshooting and stuff, explorer.testnet.near.org sounds like a good thing to paste into the chat, doesn't it? Okay, cool. There it is. And then we go down, decrement is the same thing. And now we have new function reset. Super simple, we're setting the value to 0. And this is a new function after counter has changed. This is pointless function, like does nothing, but it's just to illustrate that we have these public functions up here, right? You can call this externally in a transaction. Like when we were clicking minus, we were calling the public function decrement. And then just for funsies and just to sort of like make people feel like, like what's possible and what's not possible, we're calling this private function after counter change. And so, yeah, you can have private functions too, just, remove the pub and notice that this is not inside of this big block either. So this is more just for a demonstration of like what can be done. Now, the bottom part is what I usually would think is like the super boring part, honestly, of like writing tests. Yay, writing tests. No one likes doing that. Almost no one actually does it, even in the professional world, unless you're like near or a real hardcore company. But in terms of writing tests for a smart contract, that's a different story because this is like a whole new like method of like development. I'm not going to get into this too much because I can see we're already a little short on time, but I want to show why testing is so important. Okay, I'm going to go back to the slide here. So here is basically a way that we can do this. And I think there's a few more steps we can add, but seeing as the hackathon is ending tomorrow in the evening, you may not even want to do the simulation tests quite yet. This is just like, here's how you do it really quickly. So this is how I would do it personally. Start with an example, near.dev, add and modify functionality, write tests. All the tests that we have in that repository are like super easy to see what's happening. We have a bunch of tests, so I won't go over like how exactly they work. I think if you just like stare at it, then you'll get the understanding through osmosis. So you write tests for the new code, then you run the tests using like a context. Like when you run tests, it gives like a fake blockchain essentially, and says like, hey, this is exactly what it would do in the blockchain context. And then you move on and build stuff. But like these 2, 3, and 4 steps, these are kind of like the cycle. You want to add and modify functionality, write tests, run tests. Change it again, write a test, run it. And I'm not saying this because I'm a stickler on people writing tests at all. It's actually like how you do things in smart contract development, honestly, because we don't have that main entry point, so we can't do cargo run, okay? So if you want to like add a little bit of stuff and then you're like, wait, how can I like try it, right? Well, you don't want to like compile it and then basically like upload it or deploy it to the blockchain and then try to run it there. Just do it in tests. So tests are actually much more of like just the normal workflow. Okay. So this is something that is really useful. So we saw the cute Game Boy front end, but actually I think that Rust is like a systems programming language. We don't want to deal with like cute front ends. We're gonna skip all that stuff and we're just gonna go straight to like the terminal. Just boom, let's go to the command line like real systems developers. And this is a really important tool that was installed for you in Gitpod. And if you are gonna move on from like not using Gitpod and you were like, hey, I'm super interested, I want to do this on my local development machine, make sure you have Node.js. That's just kind of an important rule in life. And it's npm install tacg near shell. And so here, if I type near, let's see if folks can see that. I just type near because it's installed here, and it shows a bunch of commands. So I can create an account, I can delete an account, I can build, deploy is obviously super important, all this jazz. So we're going to be using that. So another thing that I've done here that's going to be useful. Notice how like you did not actually have to create an account until you were interacting with the Game Boy. But what was happening there was you were creating an account that was getting allowed to press plus and minus on the Game Boy and reset, right? So something else happened where we actually deployed a smart contract of this whole counter logic to the blockchain for you. And that happened kind of behind the scenes, you know, like we wrote some code that like lets you do that. If you want to see where that contract name is, you can see that it's there. So you kind of have like two contracts, right? Or sorry, you have like two accounts right now. One of them had a contract deployed to it. And by the way, account and contract are sort of synonymous. You create an account and you can just keep it like that, or you can deploy exactly one contract to it. Those are the only two options. No multiple contracts per account. So if you wanted to, you can actually just skip the Game Boy and you can call this function directly, which would be like near view contract name get num. And we're running super low on time, so I'm gonna like breeze through this. But you, in your Git pod, you can do this and you'll see that it's actually like working as expected. And you notice that this is a command that's called near view, right? Let's just keep that in mind. And so that was kind of cool. But what if we want to do something different? We want to increment this counter from the command line, not from the Game Boy. Okay, well here's the command, and it looks kind of long, but you know, compared to the last command, it's not that crazy, right? The only difference here is near call, and then we say, I am calling this contract. Okay, cool. What method do you want to call? Oh, it's called increment. It has to match, including like underscores or anything. I am calling this contract on the method increment. And when you do a call from in blockchain, basically, you need to say, okay, I am so-and-so. And so we have this flag called account ID. And we say, okay, my account is contract name. And like when Gitpod was set up and all that jazz, then you have the keys to that account. So you have the power to literally like delete that account and brick your account if you want. You have all the keys. You're the only one that has the keys. And yeah, so near view doesn't need you to have that end account ID. Near call definitely does. Okay, we are gonna go real quick here. And the cool part about this is we can do these same call methods using your new account that you just made. We'll do that in 1 second and then probably wrap up there because just time constraints. And I will say right now that like I'll be on Discord. I'll be able to answer tons of questions and all that jazz because there's a lot of stuff that I wanna go over here that I think is gonna be really interesting. But I think we're gonna have to call it a little bit short. So, but I do think it's important to like kind of like bridge the gap here between like what happened with the front end and you know, earlier with that Game Boy where you press a button and it actually talks to the blockchain. So here is the file that you would want to look at. And this is like plain old JavaScript. We have view methods and change methods. This is in source main. And so as you're tweaking these examples, this is where you want to look for changing your methods. Change methods, obviously change it. View methods was the view. And yeah, I'm going to cut it kind of short. I will go over some troubleshooting stuff because I think that's really useful. And I want to unblock anyone as everyone's going to be drinking monsters and staying up late. If at least I would. Okay, if you end up like deploying a contract to an account and something goes terribly wrong and you look in the console when you see this error, then you may want to actually just like delete an account and then remake it. Again, I think this is something I can cover a little bit later in Discord. So that is one kind of gotcha. This happened to me one time. You may not ever see this, but if you happen to see a weird like transaction canceled, make sure that your little Game Boy guy is signed out. If you see this in your Game Boy page, port 123 didn't respond, that's probably just means that you walked away, you know, for like an hour and came back, and the Docker container with containing Gitpod just said, hey, you haven't talked to me in a while. I might as well shut down. And all you got to do is just, you know, just restart it. Super easy. And okay, yeah, I guess this will be the final thing too to say is this is like a super simple like counter example. Then we have the near.dev examples. Now, if you're into JavaScript and all that jazz and you love the hotness, we also have this React app. And this is just like npx create near app -- rust, and then whatever your directory is. So that's my-near.app. -app. And this is also available on near.org as the first kind of like banner. So if you're like, hey, I don't want to do plain vanilla JavaScript, but I want to do something more fancy and have it be reactive, boom, you know, we got one for you. So I think I'll cover more of the like deploying action inside of Discord, but I think we can probably leave it at that, John, and have this be sort of like to be continued in live form.
That works totally fine by me.
Awesome. Any kind of questions in the chat for the next couple minutes? Rust is not actually that scary. I think it takes a little bit of like getting used to, I suppose, but it's pretty neat. It's pretty neat. Yeah. I will say, as you go on and you end up kind of building this, there is if you get errors in the console as you're trying to like build Rust, notice that there's going to be some hints in there, and sometimes the hints will even tell you exactly what you need to do. So it may say, hey, this didn't compile because of, it looks like you may have forgotten an ampersand here. And that may be like actually just telling you, like, just put an ampersand right on this exact line and it'll work. So always check the console for errors. But again, I think that I need to give a little more context in Discord about that whole kind of build and deploy process.
I think you got a question.
Cool. Yeah, if you want to store a string on the blockchain, how do I implement it? Yeah, good question. And I would highly recommend going to status message. Status message right here, if you can see it, there's Rust status message. This does the exact same thing. And actually, this is a really cool example where we are not just storing a string, but we're saying we're storing a string for you, and we're storing a string for whoever else called this. And so it implements a collection for that. So, you know, in this example with a counter, anyone that called increment would increment the same number. This is saying like, we're going to have a string that's dedicated to you. But pretty easy. I would definitely check that out. All of the Rust examples here, if you just like search for Rust, do a great job. Yeah. Cool. Well, I guess thanks so much for the time, and look forward to seeing the projects. I'm really excited. There's a bunch of people. I saw the list of people who are involved, and this is just really cool that there's so much engagement. I look forward to answering a bunch of questions in Discord. Cool.
Awesome. Thank you so much, Mike, for doing the talk. And yeah, if anyone has any more questions, feel free to PM or DM anybody from Near about any questions. All right, with that, I think that's it. Happy coding.
Okay, thanks.
Thank you again so much, Mike.
For sure.